Hardware tests, the same. For the hardware, a lot of things must be done. Failure rates, diagnostic proof tests, fail-safe design, low and high demand mode, safe failure fraction, FMEA, DACA, Markov modeling. Now we come to the PFD and PFH. With wonderful number, you believe, and I will show you now what we can do with these numbers. We need numbers, of course. PFD, lambda values, but which one? Small example. We have two different kind of, or major kind of standards, IEC, ISA. I use that one. When I talk about above SIL, how many standards do we have? At least 4. Senelec, 50, 126, 29, 28. IEC 65008, ISA, and 6262, 1. Different standards, different SILs, total different calculation methods, but we have all in common, SIL 1, SIL 2, SIL 4, 3, 4. Which do you use? One of the problems we're facing here, 65008, this is the calculation for the PFD, and this is the calculation for the ISA 84002. Look on this equation. It's a big difference. The next one, well, this one was a 1 out of 1 system. Tino mentioned it before. Now we go to a 1 out of 2. Look to that, and look to what small thing. You compare systems with numbers, but you have to know which number you compare. 2 out of 3, my favorite system. I have some additional commands to Tino. Tino knows the commands. If you run a 2 out of 3 system in a safety purpose, and you lose one of the components, you have to shut down. When I'm the expert to investigate your fault, your accident, you will have a problem. Because a 2 out of 3 system, when you lose one, you have a 2 out of 2, and that is not a safety system. You have seen where. Because the systems are voting. And what do you do when you vote 50 and 50? Oh, yes, right, we are right. No, you are wrong. The common cause failure, both are wrong. Look at that. This is the equation for PFD, and that simple thing is the equation for ISA. Now you can imagine, when I use that numbers, common numbers in the industry, and put it in a graph, and do it for 1 out of 1 system, and calculate with a diagnostic coverage factor 99%. 99%, what is it? High, low, medium? What do you expect? Who is for medium? Me? Okay, you also. 99 diagnostic coverage is medium because the standard gives us 60 to 90 is low, 90%. 90 to 99 is medium, and above 99 is high. Now imagine, you have seen the wonderful HiMax system. The analog input board has 5,000 components on the board. And we have a diagnostic coverage factor for 99.98, which includes the software. It's a lot. With the wonderful certificates, look who is making this certificate. In a EN 45011, chapter 4.2, is written, in particular, the certification body has to make corresponding commitments to be able to take liability for measures and actions. Look on this fantastic certificates crossing around. A small sentence on each side, on each page. We don't take any liability or responsibility for our calculations or whatever. With certificate, you can put in a wastebasket. When you have a certificate, with things must be on, and no sentence is here, we don't take any responsibility. Certification body, certification number, product tested. You have to test the product independently. Type, and so on, and so on. And when you have the security, what with certificate shows something, what you can use to protect you and your company. To avoid for future problems, you have seen I've talked about numbers. And with numbers are very important for safety. And we need methods and tools which give us numbers which are correct. And therefore, the TUV and the university, my institute, decide to develop two things. On one hand, the TUV installed a database with certified and validated components. And we as university built up a tool which can be provided to the end customer to calculate loops easily in a correct manner.
So the TUV in Rhineland, in
Cologne.
Where this data is on a server there.
All the major manufacturers of sensors, actuators, and safety systems are in this database. And we build it up, and we will install it end of the year officially. But I will show you upfront with things. This tool is certified by TUV, and all data you have seen here given corresponding to the database. We can look in and see what is, I hope it's right, yes, how the system is built, how the data are. And this gives us the opportunity, or not us, you as user, make loops calculation in a correct way, which is according to international standards. This tool should help to come to a common calculation method for you as user of safety components